Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad KHAIRUL HAZIQ bin MARZUKI. Today I want to present about my final year project 2, which is the study of different piping wall thickness against the different pressure applied at UTHM biodiesel plant using simulation method. Okay, first of all, as you can see the below of the title, this is my supervisor, which is Sir Baci bin Abu Bakar. This presentation, I will focusing on about the explanation about my poster. Okay, as you can see in this slide, this is my poster from start until the end. For the first thing is about my abstract of my project study. Okay, the study is concerned about the withstand of the piping system at UTHM Tun Hussein on Malaysia of biodiesel plant against the variation of applied pressure. Second is to perform it using the SolidWorks 2020 software simulation method and not the empirical method. Next is in simulation, I do two methods, which is computational fluid dynamics (CFD) and also final element analysis (FEA). Next, the thickness that being used default thickness is 3.91, which is 2 inch for the schedule. Wall thickness for the piping system that is used at UTHM biodiesel plant is acceptable at the end of my project, because it's already comply with code and standard ASME B36.10, and it is acceptable and complied. Next, for the two other thickness that I analysis, the result for 2.77 and 5.54 millimeter for the wall thickness are also acceptable and not fail, but not economical in terms of safety and cost of material for it. Introduction. Okay, this project aims to compare the capability of the piping system at different pressure tests. The pressure applied for this study is around 8 to 12 bar for normal operating running. Okay, it start my project by measuring at UTHM biodiesel plant. Next is the purpose of this simulation is to investigate the withstand of the wall thickness in the piping system based on the pressure selected applied. Next is to predict the mechanical properties of the wall thickness using the FEA and CFD test in order to minimize the maintenance cost for testing. Next is the wall thickness selected is for A53B carbon steel pipe from the outlet boiler to the steam header at boiler room UTHM biodiesel plant. For the methodology, the simple methodology that I create in the poster. First is I measure the pipeline at UTHM biodiesel plant, which is outlet boiler to the steam header. Next, I sketch all the part and assemble the model by using the SolidWorks 2020 simulation software. Next, after I sketch and assemble the model, I analyze the withstand of piping system against the pressure applied using simulation method, which is CFD and FEA test. As you can see in this picture, I measure the size of the piping, the thickness of the flange, and also the picture of the parts in SolidWorks simulation software. This is about the literature review that related to my project. First is Yan 2015 said that the elbow pipe usually the highest pressure stress located for the flow distribution pressure that I will try to do in CFD test. Okay, next is Tawensi 2013 The carbon steel material for making a pipe is also famous material that have been chosen for pipeline. So at UTHM biodiesel plant, the outlet boiler piping is used is carbon steel A53B. Next is CN180080. The more flow distribution of the fluid is applied is related to the velocity, which is the higher velocity is working fluid and vice versa. Next is the Lera 20 and 18. The appropriate design safety factor should be described to reach this target safety level. However, it's also to avoid the unnecessary conservation. This is related to the safety factor of the thickness pipe. For the first simulation is I use CFD to investigate the pressure distribution. As I can see in this first picture, the highest point located for the pressure distribution in flow is at elbow, the first elbow. So it is tally with the literature review, which is the elbow is the highest part of pressure stress located. Next, we go through the velocity distribution. The velocity distribution analysis said when the pressure apply, the increased pressure apply 8 bar to 10 to 12, the velocity also increase at the end of the piping system, which is the continuous of the force given, the more velocity is go. Next, for the analysis of FEA, after I get the highest pressure, which is elbow, I go to the FEA test and apply for the stress and strain simulation. For the stress is we can see at the bar chart at 8 bar pressure. So we can see that when the wall thickness is lower, so the stress it will be high. As you can see in this bar chart, when the thickest of the wall thickness, so the less of the stress pressure is analyzed. Next, for the 8 bar strain analysis, also do the same part, which is elbow part. The same result is shown to same goes as stress, which is berkadar langsung. The highest of the wall thickness semakin tebal, so the strain also will low. The low of the strain will be can be seen, which is the deformation. Strain is about the deformation of the material. So the height of the wall thickness, the low the strain value analysis. Next is the comparison for the stress analysis. As you can see in upper bar chart, all the three thickness is tally with semuanya adalah tally dengan result yang diperolehi. For the thick paling nipis 2.77, the highest of the stress also still in the highest compared to the 3.91 and 5.52. And for the bar, for the pressure applied, the more pressure applied, so that the more the stress is obtained. Same goes as the strain analysis. When the more pressure applied, so that the more of the value of strain can be seen. Okay, that's for the strain analysis. As a conclusion, the wall thickness for the default piping system outlet, the boiler that is being used at the UTHM biodiesel, is already the exact and acceptable selection. The pressure is applied at normal operating procedure, which is 10 bar at the normal operating. The yield strength of the material when doing the stress analysis is still not over than it, so it's safe to be used for the current wall thickness at the UTHM biodiesel plant. Next is the acceptable. It is acceptable and comply with the code and standard as may be 36.1 code and standard, as it is successful to withstand the pressure applied. So this is the conclusion for my study. Furthermore, the result for 2.77 millimeter and 5.54 millimeter for the wall thickness, it also acceptable and not fail, but it is not economical in terms of safety and cost of the material. So that's all from me. Thank you.